Hey everyone, welcome to the 2024 React beginner course. In this course you will quickly learn what React is, how it works and how you have to think when you build applications with React. This is a beginner friendly course. We will start simple and then step by step learn more advanced React concepts, and we will even use TypeScript and Tailwind CSS, which are technologies that are used in many projects these days. So you wanna hit the ground running and learn how to use them right away. If you don't know what any of this means, don't worry, you will learn all of this throughout this tutorial. We will also learn how to organize our React projects, how to split up code into smaller components, and even how to create our own custom hooks. We will also learn common React mistakes in the process and how to solve them. So what are the prerequisites of this tutorial? Well, it would be perfect if you already have some basic knowledge in JavaScript, HTML and CSS. Even if you don't, even if you are a complete beginner in web development, you might be able to follow along with this tutorial. You might need to look up some basics here and there, but you can always use Google for that or fill in the gaps later after you finish the tutorial. You don't need any pre-knowledge about React, TypeScript or Tailwind. We will learn all of this in this tutorial. Let's take a quick look at the project we will build here. So I think for a beginner there is no point in building large fancy projects with a ton of features, because it's important to really understand the basics of React and not just copy a huge project that looks good but in the end teaches you nothing because it's too complicated. And the perfect React beginner project is just a simple to-do list app where we can tick off to-dos. We have some information here on the screen. We can delete to-dos and we can add new to-dos. And this will teach you so much about how React works, so I recommend that you follow along through this whole project and you will learn a ton about React in the process. And one more thing before we start, I have a free React Best Practices mini email course. This course is the perfect complement for this beginner tutorial. I really recommend that you sign up. You can find it at codingandflow.com/reactbestpractices. It's a short email course that will send you a small lesson every day, a small video lesson where you learn one React best practice. It's a lot of fun and it's very easy to follow along. Alright, and then let's start learning React. So as the IDE, so the software where we write code in, we will use VS Code, which I would say is the most popular code editor for web development. It's completely free to use. Just download it, install it, and we are good to go. Next, to run a React app, we also need Node.js installed. You can check if Node.js is already installed on your system by opening a command line window and typing in node-v, which is short for version. And it shows that I have Node 20.9 installed. If this says Node is not recognized, or if your version is below 18, then go to nodejs.org and download and install the latest LTS version. LTS stands for long-term support. It means that this version will get bug fixes and security patches for a few years. Again, we need at least Node 18, so it's a good idea to just install the latest LTS version. When you build a new React project, it's recommended to use some kind of framework, because this way you don't have to assemble the whole project manually. You don't have to wire up everything yourself. Now for real production apps, I usually use Next.js, which is a full stack React framework that adds a lot of cool features on top of React, like an integrated routing system or backend API routes. But to learn the basics of React, I think this is a bit too much. So instead I want to use Vite, which again has the benefit that it assembles the project for us and it just works. But at the same time, Vite is more bare bones. We don't have these ton of features on top of React. We basically just have React. If you want to learn how to build projects in Next.js, you can watch my other tutorials. I have a lot on my channel where we build a lot of cool full stack projects. But yeah, here we will use Vite. And here on its homepage, we have this getting started guide where we can find out how we can create such a Vite project. We actually only have to run a simple command in the command line. So what we do is we go to the folder where we want to put this project. You can put this on your desktop or in some other folder, doesn't matter. Here we want to open the command line. On Windows we can do this by holding Shift down, right clicking, and then we open the PowerShell or command window here. And here we type in npm, which stands for Node Package Manager. We have this available because we installed Node.js. and then create space Vite add latest. We confirm this with Y, and then we have to do some configuration. First, we have to give this project a name. Let's call it 2024 minus React minus beginner. The name is up to you. We confirm this with enter. Then we have to select a framework, because Vite actually works with many different frameworks. We of course want to select React. As the variant, we want to select one of the TypeScript variants. What is TypeScript? Well, TypeScript is a superset of JavaScript. It's JavaScript but with types added on top. The problem with normal JavaScript is that it's dynamically typed. You can pass any value to any function and you can put any value into any variable. This can easily cause bugs and problems, especially in larger projects, so most people these days use TypeScript, which makes sure that we can only pass the values that we actually expect. For example, here we declared that this is an array of to-do objects, which has this exact structure here. The completed value of our to-do has to be a boolean. If we try to pass a different value, like a string, this will not compile. We cannot even start our app. And this is good, because this here is most likely a mistake and we don't want to allow this. TypeScript requires us to write a bit more code than in vanilla JavaScript, but the safety we get in return is really worth the effort. So I recommend that you don't shy away from TypeScript. It makes sense to learn this even as a beginner. And other languages like Java or Kotlin, which many beginners use as their first language, also have this strong type system. So it's not an advanced topic, it's a basic topic in my opinion. So yeah, don't put this off. Don't start with just JavaScript and plan to learn TypeScript later. Just learn it right away. Start with TypeScript and you will benefit from this greatly in the future. We select TypeScript plus SWC. SWC is some stuff under the hood which just makes this app a little bit faster. You don't have to worry what this means exactly. Just select TypeScript plus SWC, confirm with enter. And as you saw, in a split second this new project was created. Now we can actually close the command line and here is our new project folder. We open this in VS Code by right clicking, open with code. If you don't have this option, you can also open VS Code directly, go up here to File, Open Folder and open the project folder this way. Yeah, and just like this, we have a React project ready to run. As you can see, it created quite a few files with configuration for us. Everything in the src folder is our React application code, and the other files outside of the src folder are configuration. And later when we compile this project, this will also be optimized and fast. And this is what a framework like Vite does for us. So what we do now is we open the terminal. You can find the command for this here in View and Terminal. I use this shortcut, Ctrl-Ö. Then we run npmi or npm install. npmi is the short version of it. This installs some packages that are listed here in this package.json. This contains React, some TypeScript stuff, and some other configuration. With npmi we install all of these packages. After this is done, we go into the command line again and run our project in development mode with npm run dev, which gives us a URL that we can open. Yeah, and when you go to this localhost URL, you find this template here, which has this fancy button that we can click, and we want to replace this for our own app. We will start writing code in a moment, but let's take a look at some files here. We have this index.html, which is basically the page that we just saw, which contains the HTML tag, a head tag with some metadata, and the interesting part is the body with this root tag here. As we can see, this executes this main.tsx, which is another file in our project, and pay attention to this idea, it's called root. And in this main.tsx file, we have this script that searches for this root element in our index.html. And here it renders our React app. And React by default creates a single page application. So we only have this one element here, this React page, so to speak. Now when something on our screen changes, for example, we navigate to a different page via a router, then we actually still see the same page. It's still our index.html, which renders our React app, just that whatever we put inside this app component here changes. This is different from a classic website where we make a request to the server, we get a page back and we show this page on the screen. Here we basically only make one request to the server, we get this one page back, and then everything that happens afterwards is handled by JavaScript. JavaScript replaces the content on the screen. And we can actually see this by opening this page again. We can open the Chrome DevTools with F12. And here we press Ctrl-Shift-P, search for disable JavaScript, keep the DevTools open but refresh the page with F5. And as we see nothing. Why? Because now without JavaScript, we don't run our main script and we don't put any React component on the screen. So by default, a React app doesn't work without JavaScript, which is one of the downsides. This is one of the problems that a framework like Next.js solves. It brings server-side rendering back into React, so that we get the best of both worlds. Again, you can learn Next.js through my other tutorials, but I would recommend that you watch this beginner tutorial first to learn the basics of React. And then I think it's a good idea to switch to something like Next.js. If we close the command line and refresh the page again, we have JavaScript enabled again and the page works again. Yeah, and in case you're wondering where this code here is hidden, it's in the app.tsx file. Here is this counter. You don't have to understand what useState means for now. We will learn this later. And here's the button that changes this counter. React uses a so-called declarative UI approach, whereas a normal JavaScript application uses an imperative approach. Let me quickly explain what the difference between these two approaches is, because you need to understand this in order to understand React. So in a normal web app without any fancy frameworks, your code would look something like this. We have an HTML file where we have our different HTML elements. For example, in there can be a button which shows the current count of our counter. This is what we saw a moment ago, just how it would be written in a vanilla JS app. Then separately, we have a JavaScript file which can execute code, which actually brings life into these static HTML files, because HTML by itself doesn't do anything besides rendering data on the screen, text and images. We need a JS file for all the logic, and this JS file would look something like this. It would have this count variable, it would find the button, for example via its ID, which we set here. It would add an event listener to this button, listen for the click event, and every time we click this button, it would increment the counter and then update the text of this button. This approach is called imperative because we have to explain every step along the way of what we want to do. We have to find the button first, we have to add the listener, we have to increment the count, and we have to specifically update the text content, otherwise the text here will not change and not reflect the latest value of this variable. So we have to explain every step along the way. This is the declarative approach that React uses. This is the code that we just saw in the app.tsx file, just with some of the uninteresting stuff stripped away. There we don't have separate HTML and JavaScript files. There we put all of this into a single file with the file ending either JSX or TSX. TSX is for TypeScript. And declarative means we don't explain all the steps that we want to execute. Instead, we only declare what we want to show on the screen. And the rest happens automatically under the hood. So here we don't say update the text content after our counter has incremented. Instead, we render the count value down here between these parentheses. And whenever the count state changes, this will automatically be updated and show the latest value. And this makes it much less likely that we add UI bugs to our app, because in the imperative approach, we always have to remember to do this. And this is a simple case. What if we want to change more info on the screen? We always have to remember to update the actual content of these elements. Whereas in the declarative approach, we just declare what we want to show, and then this will automatically always show the latest value, which is super cool. And React does this by just redrawing the whole screen whenever any of the state here changes. This sounds very inefficient, but React does it in an efficient way by optimizing the updates under the hood. So after we incremented this counter, React just redraws the screen with the latest value of the count in this button. But we don't notice this because this happens in an efficient way. Another benefit of this JSX syntax is that we can create encapsulated, reusable components that contain both the markup, the logic, and with Tailwind also the styling. Instead of having to jump between a lot of different files, we have everything that belongs together in a single file, and at the same time it makes it easier to organize our code. One of the cool things about Vite is, and also Next.js by the way, when we change something here, for example, let's change the text of this button, and we save it while development mode is still running, we see the changes here immediately. And we even keep our state of 11 clicks. Now just one more step before we can start hacking away. We still have to set up Tailwind, but this is pretty easy. Okay, so the way CSS usually works is that we set a class on an element. For example, on this image we have this logo class and this React class. The only difference is that in React we set this via this className argument, whereas in normal HTML this is just called class. We can't use class here because class is a reserved keyword in JavaScript, and JSX and TSX files are basically JavaScript files, so this is why it's called className here. Just one thing you have to keep in mind. And then we have separate CSS files, for example this app.css, which has selectors for these classes, and then it styles these arguments with CSS attributes. So if I want to change the styling here, I have to change these attributes in the CSS file. Tailwind CSS works a little bit different. There we don't have these separate CSS files anymore. Instead we have a ton of different utility classes, which all fulfill a specific role. If we want to make the text bigger, we have classes like TextLG. If we want to add padding, margin, or a specific width, we have separate classes for that with different number values. The benefit of this approach is that we don't have to leave our TSX files anymore. We can do all the styling directly inside with these different utility classes. Now, most people love Tailwind because they find it makes them more efficient. A few people hate it, but it's good to learn it because it's a required skill these days. In the docs, we can find some instructions on how to set this up. Somewhere here is actually a guide specifically for Vite. So let's search for Vite and open this page. And then we have a few steps that we have to do. We have already created our Vite project. Next we have to install some packages. So we copy this line here, go back into our project, open the command line again. We stop our app that we have running in dev mode right now with Ctrl-Z. Here we confirm this with a Y. And then we install these packages with this command we just copied. npm install -d Tailwind CSS, Post CSS, and auto prefixer. And this puts these new packages into the package.json file. So after this is done, we can find them in here. Let's go back to the installation instructions. Next, we have to execute this command, npx Tailwind CSS init -p. So let's do this as well in the command line, which creates new files in our project, Tailwind config and Post CSS config. Let's take a look into them. Tailwind config, which is here in the root of our project. Yeah, and as the name implies, here you can do a configuration, you can extend the default classes, you can add some default styling and some other configuration. And here we also have to copy some stuff in, which is the third step in the Tailwind documentation. We have to copy this part here into the content block of our Tailwind configuration. So right here into this array. This makes sure that Tailwind works in our index.html file and in all our JavaScript, TypeScript, and JSX and TSX files. Then let's save these changes with Ctrl-S. Then we go into our index.css file, which basically contains the default styling of our whole website, like how links are rendered, what margins we have applied by default, how headlines look, and so on. But now that we use Tailwind, all of this doesn't have any meaning for us, because in Tailwind all these components are unstyled by default, and we style them in the places where we use them with these utility classes. So we delete everything out of this file, and instead we have to add these 3 lines here, which wire up Tailwind with our project. Yeah, now we are ready to use the Tailwind utility classes. But you also want to configure your VS Code properly to work with Tailwind, otherwise this would be a nightmare, because we have to make sure that we have proper auto-completion. So what we do is we go to this Extensions tab, and then you should install the official Tailwind CSS IntelliSense extension. As you can see from the screenshot here, this will later give us auto-completion inside className strings with the different classes available. And this is extremely useful, so go ahead, install this, and then we want to open the settings of VS Code, search for file associations, and here you want to add this file association with the key *.css and the value Tailwind CSS as one word are lowercase. This makes sure that Tailwind CSS works inside CSS files like our index CSS. And then we also have to change another setting. We search for editor quick suggestions. And here you want to turn this on for strings. This way we get immediate autocomplete inside className strings. Otherwise you have to trigger this manually, which is not very convenient. Okay, lastly I recommend that you also install the ESLint extension if you haven't yet. Vite automatically has ESLint configured. It's a tool that helps you find problems in your code. Normally you have to execute this via the command line, but with this extension we see these warnings and errors directly inside our editor, which is more convenient. Okay, cool. Let's close all of this. Let's go into our Explorer here and delete the whole app.css file, because now we do styling via our Tailwind classes. Which also means in the app.tsx file, this import here is invalid. Let's remove it because this file doesn't exist anymore. And now, of course, when we run our app in development mode again with npm run dev, it's all unstyled because we removed the CSS. It's interesting to note that almost no element has any default styling in Tailwind by default. So headlines, for example, or buttons normally have some default styling in CSS, but Tailwind removes this default styling because usually it's not what you want. We can see the default styling by going into the index.css file once again and just for a moment comment out this Tailwind base directive. Now we have the default HTML styling again, which looks like 1990. So before our eyes bleed, let's quickly put this back in and then we style this stuff ourselves. So as you can see here, this page is a JavaScript function. With functions we create components in React, which are parts of our UI. A component can be a whole page, like in this case, or a smaller element. We will create more separate components later. Above the return statement up here we can put JavaScript logic, and in the return statement we have these different HTML tags, and whatever we return here is what we render on the screen for this component. So let's remove everything inside this return block, including these empty tags here, and instead put a main tag in here. In this main tag we put an h1 headline, which will say your to-dos because we built a to-do app. And then let's remove all this unused stuff. We don't need the state for now, and we can get rid of all these import statements. Yeah, and now we have our headline here, completely unstyled by default. Now let's style this. We do this by adding class names first to the main tag. With py10 we can add some vertical padding. With this value of 2.5 rem, we can see this when we hover over it because we installed the Tailwind extension. And when we save this, our main tag has some vertical padding. And we didn't have to go into a separate CSS file. And if we want to change the padding, we can add a different value, like py8 for example, without leaving this file. Now by default, this main tag is only as big as the content in it. I want to make this as big as the screen, so we add this hScreen class. And these classes are all provided by Tailwind. They have a ton of these classes. As you can see, now this takes up the full height of the screen, and I want to remove this background color again. And in the same way, we have to style our h1 headline. I want to make this text bold, which we can do with font bold, and voila. We can also make it bigger with text 3XL, for example, or a different size value. And we can center it on the screen with text center. Yeah, and this is the whole magic behind Tailwind. Now, before we continue building the rest of our app, I want to add one more package. So once again, let's open the terminal, stop the execution with Ctrl-Z, and then we npmi, which is short for install, another package called Lucid React. Make sure to spell this correctly. This is simply an icon package because we need some different icons later, and I want to keep the dependencies as minimal as possible in this tutorial. Let's run this again with npm run dev, which also means we have to refresh the page. And again, Lucid React was added to the dependencies block. In the dependencies block are all the packages that we need in production, and in the dev dependencies block are all the packages that we only need in development. When we later compile our project, we don't include these dependencies because we don't actually need them to run the app. We only need them to write the app, like our ESLint helper or TypeScript itself. Okay, cool. Now let's continue building our app. Okay, I want to render a list of to-dos on the screen. For this, I want to put some dummy data into a file. How you structure your project in React is up to personal preference, but everything that we use directly in our app goes into the src folder. In here, let's create a new file. Then we write data slash. This way we create a folder, but in a single operation. And here let's put a todos.ts. Not tsx this time, just ts, because this is a plain TypeScript file. And here I put an array that looks like this. Please pause the video and type this out by hand. Those are just 3 dummy to-dos that we want to render on the screen for now. Later we can add our own to-dos, but for now we use this hard-coded data. Now TypeScript can automatically infer the type of this array just by the data we put in there. It sees, okay, every item in here has an ID, which is a number, a title that's a string, and a completed value that's a boolean. So when we hover over dummy data, we can see ID number, title string, completed boolean. The problem with inferring the type like this is that this doesn't protect us from accidentally passing the wrong data. So as I showed you earlier, if I now pass a string here, then the type of completed is inferred as either a boolean or a string, which is not what we want. We want type safety here. We want TypeScript to protect us from these mistakes, so we want to set the type explicitly. We could declare this type in here, but let's put it into a separate file. Again, where you put it exactly is up to personal preference. I again want to create a new file in the src folder. This time we create this types folder, and in here we put a todo.ts. And to create a new type, we want to export a new interface. We export it here because we want to use it inside different files throughout our project. Let's call this interface todo, and then we make a pair of curly braces, and then we declare how this interface or this type should look. We use the same structure that we just saw a moment ago. We want every to-do to have an ID of type number, a title of type string, and a completed value, which is a boolean. We save this. Now we can use this type here by going behind the variable name dummy data. We write colon to-do, which imports this to-do interface from this file. And then we want to make this an array with square brackets. And now the difference is that we can't pass the wrong value anymore, because now we get an error and this wouldn't even compile. And the same is the case for typos. And similarly, when we later have function arguments, then we also have types there so that we can't pass the wrong data type to a function, which is very useful and protects us from bugs. So let's save this file and go back into our app.tsx file. Okay, below our h1, inside the main tag, I want to put a div. And in this div, we put another div because later we put some more elements in here and we want to separate them properly. And in here we want to render our list, our dummy data. But how do we do this? We can write JavaScript code directly in our return block of our JSX files by adding a pair of curly braces. This is basically a window from HTML into JavaScript. And in here we can put JavaScript logic. However, whatever we put in here has to return a JSX element. So either a component or one of these HTML tags, and render it here. So it has to be an expression. So to show you how this works, we write dummy data, which imports our dummy data array from our data folder. On this we call .map, make a pair of parentheses. In here we write todo, and then we make such a right arrow with an equal sign and a greater than symbol. Then we make another pair of parentheses, because here we want to return something. We want to return an HTML element to render such a to-do. This way we take this whole array and we say we want to take each to-do in this dummy data, so each of these objects, and turn it into a UI element. This way we create lists in React. So whatever we put in here will be rendered on the screen 3 times for our 3 to-dos. For now let's keep it simple. Let's just render a paragraph tag, which contains the title of each to-do. So again we add curly braces and write todo.title. And when we save this, there are the 3 titles of our 3 to-dos. Now every time you render a list in React like this, you have to give each of these list items a unique key. This key is important if the order of your items can change, because this tells React which item is which, so it doesn't update the wrong one later. So we need a key that uniquely identifies each item. This is what we have this ID for, which is unique for each element. And in a real application where you store your data in a database, you also have a unique ID, because every database has a unique ID for all of its rows. So the ID is usually what you want to use as the key for your map calls, for your lists. So here we pass todo.id. And by the way, if we don't add this, then React will also complain in the console. Each child in list should have a unique key, so don't ignore this. And now we also want to style this a little bit. We can add a class name directly to each paragraph tag, make the text a bit bigger with text LG. Then I want to add some vertical spacing between these elements. So we go inside this inner div here that surrounds our list. And here we add the class space y2. And again, you can always see what CSS values this applies by hovering over these class names. And to the outer div, we add the class names max WLG and mx auto, which gives this outer wrapper a max width and centers it on the screen, so that it doesn't go all the way to the edges of the screen. Cool. It's also worth pointing out that we can't put a for loop down here into these JS expressions, so we can't do something like this. This will not compile because a for loop is not an expression, it doesn't return something, and we can't return a UI element from a for loop. Whereas the map function is an expression, it returns whatever we returned from its block. And this is what in the end we put into the UI. But you can't do this with a for loop. You can put for loops above the return statement up here, but not inside the return statement. Okay, next we want to add some more styling to our list items to make them look like actual to-do list items, and in the process we will create our first own component. As I touched on before, with components we can create encapsulated, reusable parts of UI that can even contain their own logic. This way we can organize our code and we can make parts of the UI reusable. For example, we might want to show our to-do list on different pages, not only this app page here. By putting it into a separate component, we don't have to repeat the exact same code in all these different pages. These days in React we write components as functions. In the past we wrote them as classes, but those were the olden days where dinosaurs were still alive and we still had pharaohs. These days we write our components as functions. Okay, let's do this. Let's create a separate component for our to-do items here. So we open our Explorer again, and I want to put this into src, then a folder called components, and in here to-do item or to-do list item or to-do row, whatever name you want to give it. And this has to be a TSX file this time because it's a component, right? And here we export a default function with the same name, to-do item. And the naming convention for components is Pascal case, so a camel case but with an uppercase first letter. Whereas normal HTML tags start with a lowercase letter. Components start with an uppercase letter. You don't have to follow this naming convention in the file name. You could also give this a different name like to-do minus item in our lowercase, but I prefer giving the file and the default export component the same name. In this case, to-do item, and this is a function, so we add parentheses and a block of curly braces. Remember, in a component we have to return a piece of UI. So let's return parentheses. The parentheses are only there so that we can put the return code into a new line. And for now, let's just return an HTML div, which just says to-do item, just for now, so that we can put it on the screen. Then we go back into our app.tsx file, and instead of this paragraph tag, we render such a to-do item, which we do in a similar way how we render an HTML tag, just that this starts with an uppercase first letter, so the name of the component, and we give it a self-closing tag. And when we save this, we should see our to-do item div 3 times on the screen, because this is the layout we hard-coded in here. But of course, we don't want to hard-code to-do item 3 times, we want to render the data of each to-do item. So how do we get this to-do TypeScript object into this component? For this, our component has to accept props. Props are just function arguments to React components. Now in the Wild West, that is vanilla JavaScript, we could just declare these props here without any types and then pass them. But in TypeScript, we have to prepare a type for our props. Again, we do this with an interface. We could put it into a separate file, but for organization, it makes sense to put it into the same file as the component that uses it. The name of this interface is up to you. I usually call it the name of the component and then props appended to it. Curly braces. And here we declare what arguments this component should accept. We wanted to accept one of these to-do items, which we import from our types folder. Then down here in the parentheses, we get past the props, which has this variable name, props. And we can say this is of type to-do item props. And now when we save this, and we trigger autocomplete here with control space, we see that this now accepts this one argument, to-do. And to this we can pass the to-do variable of this map call. And now we can use this data in our to-do item component. What we can also do is we can destructure these props, so we remove this variable name and instead add a pair of curly braces. And in here is our to-do item, because it's part of the props. And now, just like before, instead of to-do item, we can render curly braces to-do.title and see it on the screen. So this is how props work in React with TypeScript. Pretty simple, huh? But I want to style this a little bit more like actual to-do items. So let's actually remove this to-do.title here. And instead let's put a label in here. I use a label because I want to put a checkbox in here. And I want to check this checkbox even if we click not directly on the box, but anywhere else on this item. And this is what an HTML label achieves. This is not specific to React, this is HTML itself. Okay, in here we want to put a checkbox, which we do with an HTML input element, which gets a self-closing tag. We set the type of this input to checkbox, and those are basically props, the same way how our to-do item also accepts props. Those are arguments to these different components or HTML elements. So when we save this, we see 3 checkboxes. Let's also make them a bit bigger. for which we have this Tailwind class called scale, and we want to scale this to 125%, just to make them a bit bigger. Okay, cool. And still inside the label, below the input, we put a span with the text of the to-do, the title. So here we render todo.title, and again we want to style the span. Now here's a cool thing, we don't have to hard-code these class names. Instead of quotes, we can also put an expression here in curly braces. And here again we can put JavaScript logic. For example, we can use a ternary operator. We can say, okay, if todo completed is true, and we use the ternary operator with a question mark, then we want to return a few classes, and if not, colon, we don't want to apply these classes. So we keep this class name string empty and only add some styling here, which will only be applied if completed is true. If completed is true, I want to make this text struct through. So I want to add this line through Tailwind class, and I want to make the text gray with text gray 400. And as you can see, we even get a color preview because we installed the Tailwind extension. So now we have this conditional class here. To see this in action, let's go into our array here, our dummy data, and let's just set a completed value of one of these elements to true. And now it's rendered in this different style. Isn't this cool? We also have to style the label itself a little bit with some class names. We make this a flex box with flex. We want to center the items with item center. We give it a gap of 2. I think most of these class names are self-explaining. We want to add a border. We want to make this border rounded with rounded MD. When you have a border, you usually also want to add some padding with P-2. And I want to change the color of the border with border gray 400. Of course, you can style this in any way you want. We want to set the background color of each element to white. And one more. We use this hover modifier. This way we can apply a class only when we hover over this element with the mouse. I want to change the background color to BG-Slate 50. So type all of these classes out, and then our elements look like this. And when we hover over them, we have this color change. And the benefit of using a label is that we can now click anywhere on this item to check the checkbox, because all of this is the label, which is connected to the checkbox inside it. Yeah, and because of React's declarative approach, we didn't have to change the styling of this last element here explicitly. We didn't have to give our code instructions and say change the background color of the text to this color and so on. We only declared how we want our items to look depending on the data that we pass in. And when the data that we pass in changes, the screen automatically re-renders with the new UI state. Okay, a little bit more styling I want to add to the app page itself. First of all, I want to have some spacing between the headline and the list. So we go to the main tag and add this space y5 class, which adds some vertical spacing. Then we go into the div that has this LG max width. Here I want to set the background color to BG-Slate 100. Again, I want to make this rounded and add a padding of 5. And now it looks like this. Really cool. Okay, but we are not done yet, because right now when we check one of these elements, even though the checkbox changes, of course this doesn't change any of this data in our array here. When we refresh the page, all the checkboxes are unchecked again, so we don't store the state anywhere. React follows this idea of unidirectional data flow, which sounds very boring, but stick with me for a minute, it's important that you understand this. Unidirectional means that our data only flows downwards. We have state in a component, and we can pass this state down to smaller components via props, as we just saw a moment ago. Because we passed our to-do state down to the to-do item, which is a separate component. If this data changes, as we saw when we changed the Boolean value here in our array, This part of the component tree that uses this data is re-rendered by React to represent the new state. So the styling of our to-do items here changed. This means we keep the state of each part of our component tree in the parent of all these different components. So let's say the first one here at the top is our app page. This one here is our to-do item. And let's say in some other component, for example, a statistics element, we also need our to-do list. Then we keep the to-do list in the parent, which is the page itself, and we pass it down as props to the child components that need this state. We could not put this to-do item state into the to-do item component, for example, because then we can't access it in the parent, and then the other child component can't access it. It has to be in a common parent, and usually you put it in the lowest common parent where you need the state. If this is still confusing to you, don't worry, you will get the hang of it as we continue building our project. But sometimes, of course, we want to update the state from a child component. For example, when we check a to-do list item, which happens here in this child component, we have to change the state of the to-do list itself. And we do this via callback functions. So let's see how we can implement such a callback function in our project. So we go into our to-do item component file and we add a new prop. Again, the name of this prop is up to personal preference. I'm gonna call it onCompletedChange, colon, and the type of this will be a function which we declare like this: parentheses, right arrow, and the return type, which is void. It doesn't return anything. However, this function takes arguments. It takes the information we need when we check an item in our to-do list. When we check an item, what information do we have to pass to the parent to change the state? Well, we need to know which item we checked, which we can figure out by the ID, and the new checked state, if it's checked or not. So we add these two values as arguments to this function. The ID, which is a number, and completed, which is a boolean. But we don't need the title of the to-do item to change the state. We only need the ID and the new completed value. Then we destructure this new prop down here on completed change. Then we go into our checkbox here. Let's put this over multiple lines and add new props. First of all, I want to say this checkbox should only be checked if the to-do item is actually completed, because right now this doesn't actually reflect the completed value in our array. So even though this is struck through, the checkbox is unchecked by default. We can fix this by setting the checked value explicitly to an expression. We set this to todo.completed. Now this is checked and we can't change the checked state anymore. We will fix this in a moment. And then we want to implement our callback. For this we use the onChange prop, which will be executed when we click such an item. In here we pass an arrow function, which receives this argument e, and when we hover over it we can see that this is of type React change event. This is what we get passed when we click one of these checkboxes. We want to call our onCompletedChange callback, which, remember, expects the to-do ID and the new completed value. For the ID we pass todo.id, that's the item we clicked, comma, and the new checked value is inside this e variable. e.target.checked. Okay, and now every time we click a checkbox we trigger this callback. But what happens with this callback? Right now we don't do anything with it, right? Now, since it's a prop, we have to now pass it to our to-do item component. Here's our onCompletedChange callback. And in here we can do something with this callback. We could pass this as an arrow function like this, but for organization, you often want to declare a separate function for it, which you can do above the return statement inside the component. Here let's put a function called setToDoCompleted. Again, the name is up to us. And this has to take the same arguments as our callback. So let's actually copy these, put them here between parentheses, curly braces, and now we can pass this function name down here as the prop value. But pay attention, we don't call this with parentheses, we just pass the name. This way we pass a function reference. We call setToDoCompleted whenever this callback is triggered. Now we don't have any state that we can update yet. We will learn about this in the next section. For now, let's just show an alert message so that we can see that we actually received this callback. So we call alert, we pass a backtick string here, because this way we can put variable values inside the string. And let's write todo with ID, $, curly braces ID, is now, $, curly braces, if completed is true, it should say is now completed, and if not, it should say not completed. So just type out this string. And if you paid close attention, you might have noticed that I forgot to set the key here. If you notice this, then good job. The key is necessary whenever we render a list. So again, let's pass todo.id here. And then let's see if our callback works. So we save everything, open our page, and now when we click an item, we will see the new state. Todo with ID 1 is now completed. We don't see it on the screen yet, because we don't actually change any state, but we can already see that this works. So next we will learn about React state and how we can actually change what is shown on the screen when we click one of these to-do items. So right now all our to-dos are hard-coded into this array. How do we make it so that we actually have state that we can change when we click these to-dos? For this we need React state, and we create it the following way. We go at the top of our app component, inside the function, we declare a const, and then we make a pair of square brackets like this. And in here we write to-dos and set to-dos in camel case like this, equal sign, and we assign this to useState, which is an import from React. You can see it up here. If it didn't import automatically, write this out by hand. And to useState, we pass our dummy data. Yeah, and from useState, we get these two values inside this tuple, inside this array. The first value is the state itself, which as you can see is of type todo array, because this is automatically inferred from the dummy data that we pass here, which is the initial value this state will have when we open the app. If we didn't pass a default value here, then the type of the state is undefined, but TypeScript can infer this type. We could also set it explicitly in angle brackets like this, but it's not necessary. The second value we get here, setTodos, is a function that we can use to then update the state. More on this in a moment. And all these functions that start with the word use are special functions called hooks in React. Hooks allow us to use special features in React, like state or side effects, more on this later. And we will even create our very own custom hook at the end of this tutorial, so stay tuned. So now instead of showing this alert message here, we want to update our state when we check or uncheck a to-do. So we call our setTodos function, which is this one here, the state updater. This function has two versions. We can even pass a new state directly by its value. For example, we could pass an array with to-do objects. The other option is to pass an arrow function in here. So parentheses, here we get past the previous to-dos. So this is the state to-dos has before we update it. And we can use this to create our new state with this arrow function. Whatever we return from this arrow function will be the new state of to-dos. What do we have to pass here? Well, we have to pass an array similar to our dummy data, but with the updated state. How do we do this? We do this by taking the pref to-dos, which contains the old state, and we map this to our new state. Map is a function that you use very often in React because it really fits to this functional nature of React. It's how you transform an array into a different array. So, for organization, let's put this into a separate line. Here we call map. As usual, when we map our array, we get past each item in this array in an arrow function. So again, we make it right arrow. And what do we want to do in this map call? Well, we want to take our old state. We want to find the element that has the ID that we just clicked in our UI. And we want to update this element to have the new updated completed state. So in here in this map arrow function, we make another pair of parentheses. And then we put an expression. We check if todo.id of this iteration in the map call is the same as the ID that we pass here. Then we know that this is the item we want to update. So we use the ternary operator and we pass the new state of this to-do. So we pass a JavaScript object. We spread the existing to-do from this map call with the title and the ID. But after a comma, we want to update the completed value to this newer completed value. So we only update this one field. If the IDs don't match, then this is not the object we want to update. This is one of the other objects in the array. In this case, colon, we just want to keep the old to-do with the old state. And even though this looks a bit complicated, this is how you update state in React. Now this is more complex because we are updating an array. If the state was just a normal string, then of course this is simpler. But here we have to map this array to the new state. And we can see that this works by replacing our dummy data down here for our to-do's state, which should now be able to actually update. Let's try this out. Let's click an item. And as you can see, now the state changes. Isn't this cool? Now it's important to note that map returns a completely new array. When we hover over it, we can see calls a defined callback function for each element and returns an array that contains the results. So map does not modify the original array, it returns a completely new array. And this is important because the way React notices that it has to update the screen is by comparing the references of the state. So when it notices that we replaced our array in this to-do state for a new one, the new array will have a newer reference, different from the old one. And this way React knows that it has to re-render the screen with the new data. This is why we can't modify the existing array directly, then we won't get our state update. Let's try this out just for a moment. I copy this map call, but I remove the Z to-dos. And here I try to modify the to-dos array directly. But now when we click something, the state doesn't change. Why? Because the array inside the to-dos state still has the same reference as before. It's still the same array, just that we modified it. So React doesn't know that it has to update the screen. We always do this via this state setters. Now, of course, by default, this state is only saved in memory. So when we check these values here and we refresh the page, it's set back to the default state again. Later, we will learn how to persist these values. For now, I want to reset this back here to false by default. And when we refresh the page, all items are unchecked by default. And next, I want to add a form to add new to-dos to our to-do list. Okay, I want to put the form to add a new to-do above the to-do list here. Now we could put this directly into our app.tsx file right here above this div. But for organization, it makes sense to put it into a separate file as a separate component, especially since this input form will also have its own state and some logic. And extracting this into a separate component is really nice for organization. So let's put a new file into our components folder called add to-do form.tsx. Again, we export a default function with the same name, which returns some UI. So we add a return block. Here I want to return an HTML form in which we can put an input field, opening angle bracket, input, self-closing tag. For now, let's save this and put this into our layout. So above this div here that wraps our list, let's put our new add to-do form component. And there it is, just completely unstyled by default because we use Tailwind. And let's also add some spacing here. So to the div above, we pass another class, space y6. Now we have some spacing. Now let's finish styling our add to-do form component. So we can add a placeholder to this input field with some text that will be shown when we haven't typed anything in yet. What needs to be done? Question mark. There it is. We can also style this input with Tailwind classes. I want to make this rounded, but only on the left side. So we use rounded SMD. S stands for start, which is the left side. The reason I want to make this rounded only on the left is because I want to attach a button here on the right side. So we don't want rounded corners on the right. Then we make the form itself a flex box and add the grow class to the input field so it grows to the full available width. Then we give this a border. We change the border color to gray 400 again and add a padding of 2. So now this already looks much better. As I said, next to it, still inside the form but below the input tag, we put an HTML button and the text will say add. There it is, unstyled as usual. We set the type of this button to submit because we are inside a form. This way when we click this button, it will submit the form and later we will decide what we do when this happens. And then of course we need to style this button. I want to give this button a fixed width of W16. I want to make it rounded, but this time only the right side, so rounded EMD. E stands for end. I want to set the background color to BG Slate 900, which is not quite black. And we want to set the text to white. And then I want to change the background color when we hover over this button. So again, we use this hover modifier, hover colon. And when we hover over this button, we want to set the background color to BG Slate 800. Now we have this light hover effect. Now by default, input fields in React have their own internal state. This is why we can type something in here, even though there is no useState for the input here in our component. This is possible because these input fields have an internal state which is handled by the DOM, so the HTML tree itself basically. And in React you have two options. You can either keep it like this and then just get the value out of here when you need it, or you can turn this uncontrolled field into a controlled field. Controlled is what we did earlier in our to-do item, where we pass the value for this input field directly and then we have to update it via a callback. These controlled input fields give you more control, no pun intended, over what you do with this input. For example, after we added a new to-do, I want to make the input field empty. With an uncontrolled input, this is difficult. With a controlled input that is backed by a state, that's easy because then we can just update the state. So let's turn our input field into a controlled input field. For this we create a new state at the top of our add to-do form component. We have already done this before. We create a const with square brackets. We assign this to useState, and as the default value this time we pass an empty string. Here again we have our state which we call input and we call the setter setInput. Again the type is inferred to a string because of the default value. And now we turn our input field into a controlled input field by setting the value to our input. When we save it like this and we put a cursor in here and type, we can't type letters in there anymore because now we override this internal state and instead we set a state explicitly. And this state at the moment is always an empty string. We never update this. This is why we can't type anything in here. We change the state again via the onChange prop, where again we get past this React event, which contains the current input. And here we can call our state setter. We could put this into a separate function, but since this is just one line of code, we can write it as an inline function like this. And here we get the new input value again from e.target.value. And now we can type something into our input field again. But now this state is stored in this input state variable, which gives us more control over it. And now we only want to do something when we submit our form, right? Let's put this into a separate function for organization. Let's call it handle submit. And when we click our button here, which is of type submit, this form will be submitted. And we can decide what we want to do in this case by passing this onSubmit function, for which again we want to pass a reference to our handle submit function. Now this onSubmit function passes an event to the handle submit function, but since we declared as a separate function, we also have to set the type of this argument explicitly. This is not inferred. To find out what this type is, just for a moment, let's remove the handle submit down here and pass an error function. And VS Code's tooltip tells us what argument this expects. It's an event of type React form event of type HTML form element. So we can pass handle submit again and use this type up here. So again, React dot form event angle brackets HTML form element. And we need this e value here to call e.preventDefault. By default, when you submit an HTML form, it will send a post request and refresh the page. This is the default behavior in HTML. In React, you often want to handle forms differently. You want to handle them with JavaScript code via this onSubmit function. And to avoid that the page refreshes, we have to call e.preventDefault. But the rest is all handled by our input state. First of all, I only want to add a new to-do if the input field is not empty, right? So we check if exclamation mark input.trim, which we call as a function. Trim removes any white spaces at the end and start of each line so that we can't just pass a string of empty white spaces. This still counts as no input. In this case, we just want to return from this function and not do anything else. If we submit a valid input, what do we want to do? Well, we want to pass this input to the parent that uses this form. Why? Because our to-do list state lives in the parent component, not in the form itself. Here is where we have to update it. We already know how to do this via a callback. So we create a new interface, add to-do form props above the component function itself. And here we pass this onSubmit callback function, which will receive the title of the new to-do as an argument and not return anything. So we declare this function argument and then we destructure these props down here. Curly braces, add to-do form props, and in here we find our onSubmit function. Then down here, still inside handle submit, we call our onSubmit callback, pass the current input state, which is stored in useState and always contains the latest input value. And one more step, I also want to set the input back to an empty string. Remember, this is why we stored the input in the state in the first place, because this way we get more control over it and we can do stuff like setting it to an empty state again. So let's save this and then pass this callback here in the add to do form. onSubmit. Here we will call add to do, which is a function that we now have to create. Let's put it below set to do completed. And later we will better organize these functions here, but for now we just keep them in this one file. Here we get passed the title in form of a string. And then we want to create a new to-do and put it into our to-dos array. Again, we can't modify the existing state, then our state update will not work. We can't just call todos.push. Instead, we have to call set to-dos and pass a completely new array with a new reference that contains the new to-do inside it. So again, we use this function where we get passed the pref to-dos. We pass an arrow function. This time we don't call .map, but we still need to return an array here. So we create an array literal. In this array, we want to put our new to-do object. So we create an object with curly braces. We get autocomplete here because the type of our state is to-do array. We set the ID to the ID of the last item plus 1. Now if you use a database, this is handled automatically for you, but here we don't have a database, so we do this ourselves. So we take the length of pref todos and just add plus 1. The title is the input from the input field, and we set completed to false by default. And then after this object here, we also want to put our pref todos in here, which we do with the spread operator, 3 dots. Because this is a completely new array, right? And we still want to have all the existing todos in here, plus our new one, which will be added at the top of the array. If you want to add the new item at the bottom of our list, then you have to put it after pref todos in this array. Yeah, and now when we save this, this should work. And just like this, we can add new todos. Nice. Now before we continue, here is a little quiz for you. You know how we can update new todos to our state and how we can update our existing state. Based on the information and everything you learned, think about how you would delete an item from our to-do list. How would you update the state to remove an element? Remember that we have to pass a completely new array. Now before you continue watching this video, please take a moment, think about this, and then write a comment on this video with your solution. And I really recommend that you do this exercise because it will help you cement your knowledge and think in React. Don't worry if you get it wrong, I will tell you the solution in a moment. It's not easy, but if you try to come up with something yourself, it will really help your learning process. So leave your solution in a comment below the video. And then let's continue by adding a delete functionality and a sorting mechanism to our to-do list. So I want to sort this to-dos array. I want to put the completed to-dos at the bottom of our list. Again, we could put the sorting logic directly into our app component, but then we would have a lot of stuff in this component, so it makes sense to extract this into a separate component for organization. In fact, I want to take this whole div that renders our to-do list, cut this out and put this into a separate component. Again, in the components folder, let's call it to-do list.tsx. Export default function as usual with the same name. And we want to return this div we just cut out. Of course, we need some props, and we also have to import this to-do item here. Then let's go above the function, declare a new interface, to-do list props. What do we need? Well, we need the to-dos themselves, and we also need a callback for uncompleted change because the state still lives inside the app component, and we have to pass the state all the way up to the parent. The reason why we don't move the to-do list state into this component here is because later we will also have a third component below our to-do list, which also needs the to-do state. And remember from the graphic earlier, we always want to keep the state in the parent of these components that use this state. So let's add these props to our interface. To-dos of type to-do array. Again, we have to import the type. An uncompleted change, which will have the same type as in the to-do item component. We just forward this whole function. And also a third one, we also want to be able to delete to-dos through this list later. We call it onDelete, and here we only need the ID of the item we want to delete to remove it from our state. Let's destructure these props down here. Again, this is of type to-do list props. And in here we have to-dos, onCompleted change, and onDelete. So we still render our to-do items here, just that for onCompleted change, we now have to pass the function with the same name to pass this to the parent. Let's go into the app.tsx file, render this to-do list here, which expects the to-dos, which is the to-dos state. And for the onCompleted change, we pass our set to-dos completed callback function. So this still works the same, just that now we have to pass it through one more level. We have to pass this callback from the page to the to-do list to the to-do item, where this callback is then triggered. This is called prop drilling, passing props through multiple layers. Of course, at a certain point, this can become too tedious if we have to pass this through multiple layers. There are solutions for this, like React Context, which we use in my more advanced tutorials, but for now, prop drilling is fine. We will take care of onDelete in a moment. For now, I want to sort this list. We can do this above the return statement of the to-do list component. Here we create a const that we call todos sorted. We take our todos state, which we get passed as a prop, and we call .sort on it. To sort, we pass an arrow function which gets passed two arguments, which are two to-dos, which are often just called A and B. And we can use A and B to sort our list. In here we write if A.completed is equal to B.completed, curly braces. Then we want to return B.id minus A.id, A.id, because from the sort function we have to return a number, and this number decides the order in which these elements are put. You don't have to understand this logic here in detail. I will show you in a moment how this will sort our elements. Below this if block, still inside the sort function, we return A.completed (1 : -1). And here you can also see why I wanted to put this into a separate component, because if we put all of this stuff into our app component, it becomes very hard to read and unorganized really quickly. So by putting this into a separate to-do list component, we keep this logic encapsulated. And also reusable, because we can put the same to-do list into another page without having to repeat this code. Okay, cool. And now, instead of rendering the to-dos here, we simply use to-dos sorted. And after we save this, our to-dos are sorted. Again, the sorting logic is in here. And what this does is, it puts all the done to-dos at the bottom. But when we uncheck them, they get put back up into our list. Of course, you can customize the sorting logic if you want, but I think this is pretty cool. Now here's an important thing to understand about React. Every time a component is re-rendered, the body of this function is executed again, which means that when our to-dos state, for example, changes, or any of the other props or state, it runs this code again. This is why it's important that you don't put any side effects like database operations directly into the body of your components, because then this will execute willy-nilly when we re-render our component, which is never what you want. We will later learn how we can still execute side effects in a more structured manner, but putting our sort function in here is fine, because this doesn't have any side effects. It just sorts this array and stores the value in a variable. Now you might be wondering, isn't it expensive to execute the sort function every time we re-render our component, which can happen quite often? And that's a good point, but calling sort on an array like this is an extremely cheap operation. It's very fast, so it's okay to execute this on every render. If to-dos was a very huge array with, I don't know, tens of thousands of elements, then it would make sense to make this more efficient. And there are hooks to make this more efficient. We could execute the sort function only when the to-dos props changes and not when any other state changes. But this is an optimization, and you should only do this if this operation here is actually expensive. And in our case, with a relatively small array, this is a very cheap operation, and we can easily execute this with every render. If you want to see examples of these more advanced cases, check out my bigger project tutorials where we implement this stuff. Okay, next I want to add a way to delete to-dos. I hope by now you left your comment with your delete logic. Don't be scared of this. Then we go into our to-do item component. And this is why we have this outer div here. Inside this div, but outside of the label, I want to put our delete button. So lowercase button. In here we want to put this trash to icon, which is an import from Lucid React, the package we installed earlier. We set the size, which is a prop by the way, to 20. We close this. There is the icon. We want to style this a little bit. I want to give this text gray 500 to make it gray. Then we want to style the div to align these elements properly. We make this a flex box to have them in one line. Item center to center them properly. And a gap of 1 for some spacing. To the label here, we add another class. We can put it at the start or end, doesn't really matter. Grow, which again makes this take up the full available width minus the icon. Then we go down to our button again. To the button we also add a class, a padding of 2. And lastly on this button we need an onClick handler, to which we pass an arrow function without arguments. Again, we don't put this into a separate function because it's only a single line. Here we want to call our onDelete callback, which we haven't created yet. So let's do that now. Here in the to-do item props, we declare the same onDelete callback that we have in our to-do list, this one here. Put it here, destructure it down here, then call it in the onClick handler, and to it we simply pass the ID of this to-do that we render here. Okay, we render our to-do items in our to-do list, right? This means now this expects this onDelete prop, and we want to forward this to the parent page. So again we pass this callback here. And then the last step is in our app.tsx file, where we now have to pass this delete callback, for which again we want to create a function, delete to-do for organization. So here above the return statement we put function delete to-do, which takes the ID of the deleted to-do as an argument. Again we have to update our state with set to-dos. Again we get past the pref to-dos. And we have to return a new array where the item we deleted is removed. And in React you do this with the filter function. So we take pref todos, we call filter. Here we get past an arrow function with each to-do. And then we want to keep every to-do in our list except for the one that we deleted. So here we check if todo.id is not equal to the ID we pass to this function. Only then we want to keep it in the array, and the one ID that matches we want to remove from this array. And this is how we update our state to delete an item. Let's try it out. We can click this button and the item is deleted. When we refresh the page, they are all back. We can also add new items and delete them. We can check them, delete them. Nice. Two more things. For one, when we add a lot of items, at the bottom there is no padding anymore. We can fix this by going to the main tag here and adding overflow y auto. Now we have the proper padding here at the top, bottom, which is just a detail. Secondly, I also want to add an empty state. So when we remove all to-dos, I want to have a little text that says you don't have any to-dos in your list yet. And this is also an interesting topic because we will learn how to render a text conditionally. So let's go into our to-do list component again. And we want to render this empty text outside of this div here. But a return statement needs one parent element. So we can't put another div here below because then we have two parent elements. So we could either wrap this into another div, but then we have an unnecessary div that we don't really need. Another thing we can do is we can use an empty fragment like this. This allows us to basically put multiple parent elements in here, which will then just be rendered inside the page. So inside this fragment, below this div, we add an expression where we write todos.length. We want to check if this is equal to 0, so if this array is empty. Then with two ampersand signs, so the logical OR operator in JavaScript, we can render a component conditionally. only if this expression here is true. So here we make a pair of parentheses, and we simply want to render a paragraph that says no to-dos yet, add a new one above, or whatever you want us to say. And I also want to style this paragraph a little bit. There it already is, but I want to center the text with text center. I want to make it smaller with text SM. And I want to set it to gray 500. Nice. And this element is rendered conditionally. So when I add a to-do, it's gone. When I delete this to-do, it's there again. And again, this is really the beauty of React. Your whole UI is in sync perfectly. You don't have to worry when to show or hide a certain text. You just declare under which conditions you want to show it. And then React takes care of always drawing the latest state on the screen. Okay, we still have some lint errors here. We just have to remove this import statement and then it's all fine. Next, I want to create a new component that shows how many to-dos we have completed. And afterwards, we get to a new important topic, and that is how to execute side effects in React. So make sure you don't miss that. So let's create a new component in our components folder. We know the drill by now. And we call it to-do summary.tsx. Export default function to-do summary. It will take some props. Interface to-do summary props. We are pros with this by now. This needs the to-dos array. So to-do array. And we also want to add a callback. Delete all completed. Because this section of the UI will have a button where we can delete all completed to-dos at once. And of course we have to pass this as a callback because the state lives in our page. Then as usual we have to destructure these props in the component arguments. To do summary props, and here are the to-dos and the callback. In this UI element I want to render the number of completed to-dos. So let's create a const completed to-dos. And we assign this to a todos.filter, where we take each to-do in this arrow function, and we only want to keep the completed ones in this list. Again, this filter operation will be executed every time this component is re-rendered, and again this is fine because this is a cheap operation. We can do this directly in the component body. And then we render a UI element. We put a div in here, which we style with text center and space y2. In this div we put a paragraph tag, which will render completed to-dos.length. Then outside of the curly braces is slash, another pair of curly braces, to-dos.length, the unfiltered array, and then outside it will say as text to-dos completed. Let's save this for now. Put this into our app. I want to put it outside of this div that contains the form and the to-do list. So below the div, above the main closing tag, we put the to-do summary component, which requires that we pass the to-dos list to it, and this delete all completed callback. For now we just pass an empty arrow function like this, so that the code compiles, but we handle this function later. And there is our text. Now let's refresh the page and check one of these components, and as you can see, the state updates immediately. I want to style this text a little bit, so we add class names to the paragraph, text SM and font medium. And then what I want to do is, if this number is above 0, I want to show a button that triggers our delete all completed callback. We already know how to do conditional rendering, right? So below the paragraph, we add a pair of curly braces. We check that completed to-dos.length is greater than 0. Use our two ampersand signs to render a component conditionally or a normal HTML element, parentheses, In here we put a button, which will say delete all completed. The onClick handler of this button will call our delete all completed callback, and then we style this button with text red 500, hover colon underline, text SM, and font medium. So those are all the classes, and this is the result. This button is only shown when we have at least one checked to do. So let's format this properly, save this, and then handle this callback here in our app page. So we need a new function called delete all completed to-dos. We don't need any arguments here. Again, we need to update our to-dos state. Again, we need the breadth to-dos. And again, I recommend that you pause the video for a moment and try to figure this out yourself. We already have the normal delete to-do function, right? How would we write this to filter all completed to-dos? It's not that difficult. Okay, so 3, 2, 1 solution. We call breadth to-dos. We call .filter again. But this time we filter all to-dos that are not completed. So we put an exclamation mark here in the beginning. We only want to keep the to-dos that are not completed in this new array and set our new state from this updated array. And now we simply have to pass this function down here by its name. And that's it. And then we can check to-dos. We can delete them all at once. We can add new to-dos. We can delete them as well. And there is a bug in our UI, which of course I put there totally on purpose, I swear. But it's a pretty simple bug. Here for the ID of the new to-do, we pass the length of the current array plus 1. The problem is this way we use values that we already used before. Because if we add a fourth element and remove the third one, and then add another fourth element, then 2 elements will have the ID 4 and our list will not work properly anymore, as we just saw, because this deleted the wrong to-do when I click the delete button. So again, in a real production app, this ID is coming from your database, so you usually don't have to worry about this. But here we need a unique value, and a simple way to handle this is to just use the current timestamp in milliseconds with date.now. This should suffice. Now every ID should be unique and our list should work properly. So let's see. We delete a few items, we check some, we delete some more, check, uncheck, check, add new items, delete one of them, and it all seems to work, right? Okay, next we will learn about side effects, and then we will create our own custom hook to better organize our code, and then we are done with this beginner tutorial. But you don't want to miss these 2 topics. Okay, we already know that we can use callbacks to execute some code when we click a button or submit a form or have some other user event. But sometimes you want to execute a side effect when a state changes or when you render the component on the screen for the first time. Now again, we can't put this logic directly into the component body because then it will be executed with every single render. Instead, we execute these side effects in a useEffect, which is another important React hook. Let's put it above our functions here, but below our useState. We call this useEffect hook, to which we pass an arrow function, which gets a block of curly braces. And then we have to pass a second argument to this function, which is an array. This array contains the dependencies. When we don't pass anything inside this array, this effect will be executed when we first put this component on the screen. Not with every single render, only the first render. When we put a state in here, like the to-dos state for example, or we can also put a prop in here, then this effect will only be executed whenever this value changes. For this example, I want to store our to-dos state in the local storage of the browser to save the current state across refreshes. But doing this with every single render would be very unnecessary, right? But we also don't want to have to click a save button. Instead, we want to save this whenever the state of this to-dos array changes. So whenever we add or delete or update an item, we automatically save it to local storage. So, and in here we just have one line, local storage.set item. We have to give it a key in form of a string. Let's call it todos. And in local storage, we can only save strings. So we write JSON in all uppercase, .stringify, and pass our to-dos array. And this turns this into a string and saves it in local storage every time the to-dos state changes. And we can already see this in the Chrome DevTools. With F12, we can go to the Application tab. Here we can view the local storage. There's already the to-dos array. You can see it down here. And now whenever we change something, our useEffect stores the updated value in local storage. And it's always up to date. But when we refresh the page, we also want to load this state from local storage, right? We could do this in another useEffect with an empty dependency array, which again gets executed only when the component is rendered on the screen for the first time. But a simpler and more efficient way is to do this directly in the useState initializer. Instead of our dummy data, we can also pass an arrow function here like this, execute some logic, and then return the initial value. In here, we want to get our saved to-dos from local storage. Since we turned them into a string, we have to turn them back into an object, which we can do with json.parse. And in here, we pass local storage.getItem with the same to-dos key. Make sure these keys here are identical. But getItem can return null if this key doesn't exist. In this case, we want to fall back to an empty array, but this has to be a string because we are still inside this json.parse function. Okay, so we have our saved to-dos, and now we want to return this. But we want to check if saved to-dos.length, we don't get autocomplete here because it doesn't know what type this is. We can set the type explicitly as a to-do array. So if saved to-dos.length is greater than 0, question mark, we want to return saved to-dos. Otherwise, I want to return the dummy data. So if we delete all our items and we refresh the page, I want to put the dummy data into local storage and into our array. So this is what we put in here. Let's refresh the page just to be sure. So now we can add new items, we can check off existing items, and when we refresh the page, we get the previous state. Nice. Now this is stored in local storage. When we delete all to-dos and refresh the page, we get the dummy data again, which again is saved in local storage. So now you already know 70% of the stuff that you need in React. One more thing I want to do in this tutorial. This logic here is really messy. It's a lot of code in this one component, right? We can organize this better by putting it into a custom hook. So let's do that next. So as I mentioned before, all these functions here that start with the word use are called hooks in React. useState, useEffect, and there are some more. These hooks can only be called inside components or inside other hooks. And how can we create our own hook? Well, we simply create a function that also starts with the word use. So let's do this. Let's create a new file in the src folder. First we create a folder called hooks, and in here we put a hook called use_todos.ts. Not tsx, just ts. Here we export a default function called useTodos, this time with a lowercase u, because this is not a component. And then we go back to the app.tsx and we take all of this code. We start here at the to-dos state with the useEffect and all our functions. everything above the return block. We cut this out. We paste it here directly inside our useTodos function. We have to fix some imports. So let's import all of this stuff. I just removed the last letter to use auto import. We need our dummy data, useEffect, and that should be it. The other ones are just unused functions. So why do we have to call this useTodos? Now when we try to change the name, for example to getTodos, we actually get a warning here, which says React hook useState is called in function getTodos that is neither a React function component nor a custom React hook function. React component names must start with an uppercase letter. React hook names must start with the word use. And that's the whole point here. Whenever you want to extract React hooks into a separate function, this function has to start with the word use. That's a naming convention. And this naming convention is enforced because otherwise React developers wouldn't know that inside this function we use React hooks. And this would make it really hard to write and debug React code. Because if state and side effects are hidden in normal looking functions, then it makes it really hard to understand what is going on. This is why we have this naming convention. And this is how you create a custom hook in React. It's not magic. The hook can also take arguments if it needs some. Ours doesn't. But we still need a way for our app page to use these functions and values in here, right? And we can do this by simply returning them. So all the way at the end of this function, we add a return statement. And here we return the todos state, our different functions, set todo completed, add todo, delete all completed, and delete todo. This should be all of them. Then we go back into our page. We create a const that we destructure, and we call our new useTodos hook. And in here we find all these values. Our state, add todo, set todo completed, delete todo, and delete all completed. We remove the unused import statements. And now our app works the same way as before, just that our code is much more organized because all this logic is hidden in this hook. And again, we can reuse this in different components if we want to. Let's try if it still works. Refresh the page. It's still stored in local storage. We can add todos, delete completed, and it all still works exactly the same. Perfect. I hope you enjoyed this React beginner course. Again, I highly recommend that you also get my free React Best Practices email course. It's the perfect complement for this tutorial. I will teach you a small React Best Practices every day for a few days. Again, you can find it under codingandflow.com/React Best Practices. But of course, this is just the beginning. There are more topics you have to learn, like how to use databases, routing, fetching data, metadata, server-side rendering, and some more advanced React hooks. I always recommend that you learn these advanced topics by just building projects because this is the most fun. And I have a full web dev playlist here with a ton of different projects. Most of them are in Next.js. I also have a Learn course where we build a separate Express.js backend. Whatever you prefer, just check out my web dev playlist. If you want to learn Next.js in particular, I have a Next.js 14 beginner tutorial, but it's inside this playlist as well. So I will link the playlist and all the other resources you need. Don't forget to subscribe to the channel for more tutorials in the future. And also please leave a like on this video because it really helps this video and this channel grow. And if you know someone who would like this tutorial or any other of my tutorials, please share them because this really helps me, which in turn motivates me to make more videos. Alright, and then I see you in the next video. Happy coding, take care.